This video is about using trend lines to make predictions. So we use trend lines with scatter plots. Scatter plots is just a type of graph. And so what we're going to do is after we look at our scatter plot is we're going to try to find a line that best fits what the scatter plot is doing. And then we can use that line to make a prediction about where that line might continue to go. So a trend line can also be called a line of best fit, and so you'll see those terms used interchangeably. All right, so let's just look at an example. It says Haley has a leaf raking company to help offset school costs. The table shows how many bags of leaves Haley was able to fill each hour. Use the information in the table to answer exercises 1 and 2. Number 1, construct a scatter plot of the data, then draw and assess a trend line that represents the data. Okay, so if I do 1, 3 would be right here, 2, 4 would be right here, 3, 5 is going to be right here, 4 and 8, and then 5 and 14. All right, so I definitely can see that this has a positive, right, association. This is definitely going up each time. And so what I want to do is draw a line that's going to fit where this is going. Can I do that perfectly? Probably not. But I can, again, it's just an estimate. You're just making a prediction, so there's not going to be necessarily a completely right answer, but it should be in the ballpark. All right, so in order to do that, I need to draw a line, which it would be useful to have a ruler, but I don't, so I'm going to use what I've got at the moment. And I'm just going to try to figure out the line I can draw that best kind of goes like between the dots. All right, so let's say this is my line. And you can see that sometimes points are not on the line. Some are above and some are below, and that's just normal. All right, so now I'm going to use the line of best fit to make a prediction as to how many leaves Haley will have filled at the end of 7 hours of raking. All right, so if I look at my line, then at 7 hours, I can see it's about 15 bags. So that's going to be my prediction. After 7 hours, she can do 15 bags. All right. Cleo's baby pool has a leak. The scatter plot shows the amount of water left in the pool at the end of each 5-minute segment. Use information in the scatter plot to answer exercises 3 and 4. Right, so number 3 says write an equation in slope-intercept form for the trend line that is drawn. All right, so I know that y-intercept form or slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So I'm going to take that from the graph up here. So I can see that it's intersecting the y-axis here at 35. So that tells me b is going to be 35. And then I need to figure out the slope. So I need to pick a point that's actually on the line to get the slope. Let's see. It's like this point right here is on the line. So it's going from 35 to 20. And it's going over from 0 to 20. All right. So it's going from 35 to 20. So that each of these is 5. 5, 10, 15, 15. So it's going down 15. So that tells me my slope is going to be negative 15. Because it's rise over run. So I'm going down 15, and that's why it's negative. And I'm going to go over to this point right here. So 5, 10, 15, 20. I'm going to go over 20. And that simplifies by 5. And so if I divide those both by 5, I get negative 3 over 4. So my slope is negative 3/4. So now I'm going to put that into the equation. Y equals negative 3/4 x plus 35. All right. Number 4 says use the equation to make a prediction about the amount of water left in the pool after 40 minutes. So once you have an equation for the line, for your trend line, then you can use that to predict things that may not even fit on your graph. This one happens to fit on my graph, but if they asked me to make a prediction about 120 minutes, right, I could still use this formula here to estimate that without having to extend my graph. So it's pretty practical. Okay, so after 40 minutes, if I'm using the equation, then that's when I'm going to substitute in for x will be 40. Because it's the time, so that's my x-axis here. So if I use my equation, negative 3/4 times 40 plus 35, then I just have to work this out. So this becomes 40 over 1. I'm going to cross simplify because that's easier. So 4 and 40 are both divisible by 4, so that gives me a 1 here and a 10 here. That ends up being negative 3 times 10, which is negative 30 over 1, which is really just negative 30 plus 35. And then if I add these two numbers together, negative 30 plus 35 is 5. So my prediction is that after 40 minutes, the pool will be, there'll only be 5 gallons left in the pool. Okay, so then if I go to my graph and see if I'm right, okay, I can see at 40 minutes, it looks like I'm right on. It's about 5 gallons left. All right, so that's a trend line. It's just the line that best fits the data you have, the scatter plot that you have. Again, your line may be a little different than mine, but we should be pretty close in the ballpark. All right, I'll see you soon.